Hello. Many modern applications consist of containerized part of the application stack that depends on data services better suited for virtual machine-based form factors than containers. In this demo, we will look at how VMware Cloud Foundation customers can secure such an application using the Antrea CNI cluster network policies and the VMware vDefend distributed firewall, both delivered from the NSX UI. The application in this scenario consists of two containers running inside of vSphere Kubernetes service cluster, formerly known as the Tanzu Kubernetes service. The customer will access the application using the UI front-end container, which will connect to the backend container that provides the application logic. The backend will store and retrieve information from the application MySQL database running on a virtual machine. Before proceeding with the policy configuration, several verifications can be done, such as the current Kubernetes resources created in the target 3-tier app namespace, if any Antrea cluster network policies are configured, and also if the 3-tier application works as expected. The target Kubernetes cluster running Antrea CNI is integrated with NSX, which can be verified from the NSX inventory. The target application namespace 3-tier app and the two Kubernetes deployments and services are also discovered by NSX. First, we focus on securing the container part of the application using Antrea cluster network policies. When the distributed firewall policy is created, vDefend allows the policy scope to be specified to a specific or multiple Antrea container clusters already integrated with NSX. This action also determined that the policy type is Antrea cluster network policy. To demonstrate some troubleshooting capabilities that the platform provides, we begin by creating catch-all deny rule. Please note that in production environments, the default rule is typically configured as a final step after ensuring that the rules before it permits all the necessary traffic. The rule scope must be adequately specified to block only the 3-tier application traffic. To identify all the 3-tier application resources, a group based on Kubernetes namespace using dynamic membership criteria and Kubernetes labels can be used. Because the Kubernetes cluster running Antrea CNI is integrated with NSX, the Kubernetes labels are automatically discovered, transitioned, and available in NSX as tags. When the NSX group is of type Antrea, the members are not discovered before the policy is published. If no source and destination are specified, the default rule direction is in-out, which means that both ingress and egress Antrea cluster network policies will be created. The intention for this policy is only to control the ingress direction and allow all egress traffic. Because of that, the proper rule direction has to be set. As soon as the policy is delivered, the Antrea group members are discovered. The Antrea cluster network policy can be retrieved with Kubernetes CLI, verifying that an ingress rule was created. The rule name matches the rule ID shown in the distributed firewall UI. As expected, the 3-tier application stops working at this stage. The Antrea Traceflow capabilities can be used to troubleshoot and discover application communication problems. Antrea Traceflow allows to test traffic for ICMP, TCP, and UDP protocols. A test busy box spot is used to send traffic to the 3-tier application frontend load balancing service in this scenario. The Traceflow output shows that traffic is blocked by the catch-all rule. The output provides information for the rule ID and a hyperlink that directs to the distributed firewall UI, filtering the rule of interest. For the 3-tier application to function correctly, a rule to allow the ingress traffic to the front-end load balancing service is required. The definition of Antrea cluster network policy rule is different from the standard distributed firewall one. When the intention is to create an ingress rule, the destination is defined in the applied to field. For Kubernetes services, the Antrea grouping mechanism provides capability for dynamic membership based on the service name. However, The namespace must also be selected as grouping criteria. The root destination service can be quickly specified using the row protocol feature. Because the source of this row is any, a precise definition for the root direction is required to create only an ingress Antrea cluster network policy. After the policy is published, the group members are realized as effective, and the Antrea cluster network policy is updated with the newly created ingress rule. Repeating the Antrea Traceflow shows that the ingress traffic to the front-end load balancing service is matched and allowed as expected. The three-tier application UI starts functioning again, but access to the database is still not working. The reason is that the traffic from the front-end to the back-end service is not currently allowed by the security policy. A new rule is required to fix that. The source for this rule is the front-end pod, for which an Antrea group membership based on the pod labels will provide a flexible dynamic posture. As mentioned, when creating Antrea cluster network policy ingress rule, the destination is defined in the applied to field. The front-end pod communicates to the back-end service on the same TCP port 5000. The same dynamic membership criteria based on Kubernetes service name and namespace is used to define the back-end service group. When the Antrea cluster network policy rule has a specific source definition, the direction is ingress by default and cannot be changed. The Antrea group's effective membership is realized after the policy is published and the policy is updated, which can be verified from the Kubernetes CLI. At this stage, the microservices part of the three-tier application is protected by Antrea cluster network policy, and the application starts working again. The last step in this scenario is to protect the database and allow only the traffic from the three-tier application backend to the MySQL server. As the MySQL server is running in a virtual machine form factor, Antrea cluster network policies cannot be used. Instead, a standard distributed firewall policy should be utilized. The policy scope can be defined using a group with static membership based on the virtual machine. Dynamic membership criteria based on tags, virtual machine name, or operating system can also be used. Following a similar approach, the first rule in the policy is the catch-all deny rule. The reason for this workflow is just to demonstrate the distributed firewall order of operation. After publishing the policy, communication with the database is broken again. To fix that, a new rule has to be created to allow the communication from the microservice backend to the database. vDefend distributed firewall allows specific Kubernetes resources to be used in a standard distributed firewall group and policy. In this scenario, we utilize the Antrea egress resource created upfront to uniquely identify the Kubernetes outbound source IP when the backend service communicates with the database. Because this is a standard group, the IP of the Antrea egress is realized immediately with the group creation. After defining the MySQL database as a rule destination, the correct destination service, and publishing the policy, the three-tier application starts working correctly. At the same time, accessing the database from different than the 3-tier application backend sources is completely blocked. In this demonstration, we illustrated how to secure various workloads, such as containers and virtual machines, using the VMware vDefend firewall and Antrea cluster network policies. Thank you for watching.